In this lesson, we will cover Poisson distribution and Poisson process, which are significant probability concepts. Added, we will work through a real-life example using equations and graphs to help put the concepts into the proper context. Following that, this lesson will discuss about what is Poisson distribution and its method. Additionally, this topic will prepare students to solve interesting problems involving Poisson distribution and Poisson process. Furthermore, this lesson will serve as a benchmark for students who are interested in solving about probability. So before we go through to the discussion, let us have first the objective. So the first objective is to define what is Poisson distribution and what is Poisson process. And second is to identify the properties of Poisson distribution and Poisson process. And lastly is to determine the difference between Poisson distribution and Poisson process. So let's dive into the discussion. So when we say Poisson distribution, it is decided to name after a French mathematician named Simeon Denis Poisson that can be used to predict how many times an event will occur within X is a time period. So when the variable being studied is a discrete variable, so the Poisson distribution are to be used. So in advanced math and statistics, they define Poisson distribution as a discrete distribution that measures the probability of a certain number of an events occurring in a particular time period. We cannot answer a specific question if we do not know the formula. So before we go through into the examples, let us have first the formula of the Poisson distribution. So the Poisson distribution formula is applied when there is a large number of possible outcomes. So for a random discrete variable x that follows the Poisson distribution and lambda is the average rate of value, then the probability of x is given by f of x equals to px minus equal to x and equal to e raised to the power of negative lambda and lambda to the raised to the power of x divided by x factorial, where x is equal to 0, 1, 2, and 3, and so on, and e is the Euler's number, which is equivalent to 2.718, and lambda is an average rate of an expected value, and lambda is a variance, and also lambda is greater than 0. Let's move on to the properties of Poisson distribution. The Poisson distribution is useful in situations when there are many unusual and independent alternative outcomes. The Poisson distribution has the following properties. First, the events are independent. Second, the average number of successes in the given period of time alone can occur. No two events can occur at the same time. The Poisson distribution is limited when the number of trials is indefinitely large. So means is equals to variance is equals to lambda, and NP is equals to lambda is infinite, where lambda is constant. It is also a Poisson distribution table, which is similar to binomial distribution table that can be used to quickly find the probability mass function of an event that follows the Poisson distribution. Let's go on to another topic, which is the Poisson process. When we say Poisson process, it is the average time between occurrence, but the actual timing of event is unpredictable. So the arrival of an event is unrelated to the preceding event. Waiting time between event is memoryless. So the following characteristics are met by a Poisson process, although many events described and Poisson process do not exactly match this criteria. So first is events are unrelated to one another. The chance of another event occurring is unaffected by the occurrence of one. So second is the average rate or the number of events per unit of time is constant. And lastly, it is impossible for two events to occur of the same moment. Since events are not simultaneous, so each sub-interval of a Poisson process can be seen of us as a Bernoulli trial with which either a success or a failure. So let's take an example. So let's have an example of a Poisson distribution. Example number 1. In a cafeteria, customers arrive at a main rate of 3 per minute. Using the Poisson distribution formula, calculate the probability of 7 customers arriving in 1 minute. So the given is lambda is equals to 3 and x is equals to 7. Using the Poisson formula and Poisson distribution formula, which is this. So the answer is the probability of arrival of 7 customers per minute is 2.1%. The Poisson process, there are common examples given. First is customers calling a health center. Second is visitors to a website. And the third one is the radio decay in atoms. And the fourth one is photons arriving at a space telescope. And the last one is movements in a stock price.